The objective of this lesson is to write the prime factorization of a number. Let's review some vocabulary terms. A prime number is a whole number that is greater than 1 and has exactly two whole number factors, 1 and itself. For example, the number 2 will be considered a prime number, 1 times 2, and this number does not have any other factors. A composite number is just the opposite. It is a whole number that is greater than 1 and has more than two whole number factors. So, for example, the number 6. We not only have the factors 1 and 6, we also have the factors 2 and 3. Therefore, 6 is a composite number. Let's take a look at this chart down here. 24 is a composite number because it has many factors other than 1 and 24. If I ask you to list the factors of 24, you have few ways to organize the numbers. You can use either the rainbow method, 1 and 24, 2 and 12, 3 and 8, or 4 and 6. Or you can use a chart, 1 and 24, 2 and 12, 3 and 8, 4 and 6. And you draw a chart. "41" would also be considered a prime number because it only has the factors 1 and itself 41. And you can read the rest of the chart yourself. Okay, now for prime factorization, the factor tree and the monomial, I will walk through these vocabulary terms as I do the guided practice problems with you. Part A. It asks you to write all the factors of the number. I gave you a divisibility rules table in class. If you need to use it, please use it. So I would like to use a rainbow method. 1, 32, 2, 16, 4, and 8. And I believe that's it. And let's take a look at 29. 1, 29, and 29 happens to be a prime number, so these are the only factors. Now, part B, it asks you to tell whether the number is prime or composite. If it is composite, draw a factor tree and write its prime factorization. You can also use the cake method to compare your answer. On the test, if I do not ask you to draw a factor tree, you may use the cake method. If you are asked to draw a factor tree, you will have to draw one. So let's take a look at number 32. We can pick any two factors that equal 32. 4 and 8, and then let's move down the tree. 2 and 2, 2 and 4, and 4 is not a prime number yet, so we got to keep going until you end with prime numbers. And then you would write the prime factorization like this: 2 to the 5th fifth power, and that's your answer. Let me show you the cake method. Two, 1, 6, 2, 8, 2, 4, 2, 2. You also end with 5 2s. Remember, you begin with the smallest prime of the number, 32. So you end with 2 to the fifth power, which is the same thing. Okay? Now, let's move on to the number 175. Let me just erase this. And for 175, I would like to show you the factor tree again. $175. I'm going to choose 5. How about that? 5, 3, and 5. 35. Okay? And here we can keep going. And we end here. And to write the prime factorization, got 2 5s and 1 7. 5 squared times 7. And this would be your prime factorization. And for 59, this would be a prime. So the prime factorization would just be 159. But because in the directions, it only asks you to write the prime factorization if the number is composite. So you don't have to write this. And the same goes with 71. Let's move down to part C. Okay, part C says factor the monomial. What is a monomial? Let's go back up and take a look at the definition. A monomial is a number, a variable, or the product of a number, one or more variables raised to the whole number powers. For example, 5 is a monomial. X is a monomial. 5x is a monomial. 5x squared is also a monomial. Okay? And back in chapter 2, remember that this number can be considered a constant or a term. X is a term, 5x is a term, 5x squared is also a term. T-E-R-M. Okay, and now we're learning a more fancy term, monomials. So 7x, 25mn squared, 24y squared z squared, y cubed z squared are all monomials. And to your right hand side, these are not monomials because it has more than one term. 25m, negative n squared, 24, positive y cubed, positive z squared, etc. Okay, let's move down. How do we factor the monomial? We simply first factor the coefficient. Okay, here I will use the cake method because it's faster. So 2 times 2 times 7 times x times y times y times y. And that's your answer. And for 36, 2, 18, 2, 9, 3, 3. you can do this as well. And that's your answer. Okay, now let's take a look at the word problem. And let me erase. Where's my eraser? Oh, here it is. And then we're going to erase this. Can't seem to erase this. That's okay. Why don't I just draw a line here so you guys don't get confused? Okay. Coin collecting. The U.S. Mint began issuing state quarters in 1999. There was one state quarter for each of the 50 states. You are collecting the state quarters and want to design a rectangular display. Okay, so it could be like this, or it could be like this, or like this, or, many different ways. With the same number of quarters in each row. How many ways can you arrange your display? Okay, it seems like I need to take 50 and list all the factors. Okay, 1 and 50, 2 and 25, 5 and 10. Are there any more? I don't think so. Okay, so there are 3 ways, but what if we do this? We can we can do this. We can also flip it. Flip 10 and 5, 5 and 10, okay? So we have 1, 2, 3, 4, 5, 6. So 6 ways you can arrange the quarters. All right? Etc. Okay, that's all, folks, and that concludes lesson 4.1. And hope if you have any more questions, please leave a comment. Thank you.